in continuation with our previous classes, in which we have discussed about trivial nomenclature. Now let's discuss about IUPAC nomenclature. It is one of the rational systems of naming an organic compound, and it was evolved since like 1892. And we can simply uh, expand it as like International Union of Pure and Applied Chemistry's system of nomenclature for a given organic compound. So here are some salient features or basic rules of IUPAC nomenclature. The first one is one-on-one compound name rule or one-on-one feature. For according to this rule or according to this feature, it says that one compound will have only one name. That is for sure. Whatever might be the compound, in which manner we give the name, it will have only one and only one name. So as for the second feature, I can say that even for very complex compounds, naming can be done using this type of nomenclature, be it even if it's multifunctional organic compound also. Even if it's multifunctional organic compound also, we can use this sort of nomenclature and name the organic compound. It is also one of the simple, systematic, and scientific way of giving name to a organic compound. So these are the salient features, I must say. And as for next topic, I say that it's basic rules. What are the basic rules which we must know in nomenclature? So what are the basic rules in nomenclature is the thing which we'll be discussing right now. Okay, so the first, I say the first one is it's about root word. So I can say that root word is something which we have practically learned like in our previous sessions or previous classes. It's like, now let me show you what is meant by root word, or let me make you memorize what is meant by root word in a time. So do you get to remember this thing? Like in a previous sessions I have told that if in a chain, if in a carbon chain, if there are one carbon, we call it with a root word or basic unit, which is generally called as meth for one carbon. If two carbons, it's it. If three carbon, prop, 4 but, 5 pent, and 6 hex, 7 hept, 8 oct. If it's 9 carbons, we say non, and if it's 10, it's like dec. And in general, root word for any carbon chain is generally alk. You must remember it. Root word for any carbon chain in general. You're getting it? This is in general case. Is alk. And these are the alks. You're getting it now? So now let's go into second thing, that will be like primary suffixes. So this is suffix. You're getting to know what is meant by suffix. Suffix is something which we add after root word. I'll be telling the way in which we must arrange this, all the parts of a organic compound. So suffix is this primary suffix is something which that tells about saturation and unsaturation. This tells about something saturation and unsaturation. So say let me give you in a tabular form. So this is the table which I have been telling about. So if the chain of hydrocarbon it has or is saturated with a single bond, then the primary suffix would be -ane. And in general, as I've told you, root word for carbon chain is alk. We'd be adding primary suffix after the root word and it becomes alkane. If the uh, carbon chain has one double bond, it becomes unsaturated and will be having a primary suffix of -ene, and its IUPAC becomes alkene. If the system is unsaturated and is containing two double bonds, then it becomes alkadiene will becomes its IUPAC name, where you can identify here its primary suffix would be adiene. If the system is unsaturated with one triple bond, its primary suffix becomes -ine and IUPAC name becomes -ine. So we'll be in detail discussing about the examples in further lectures. And now let's go into secondary suffixes in next page. And as for the secondary suffixes, these are the type of suffixes which are added after the primary suffixes. And these will be indicating the presence of a particular functional group. So now let's have different types of functional groups and what is the secondary suffix and the IUPAC names in a tabular form. So this is the table which I actually wanted to show to you, and these are all the functional groups and these are the secondary suffixes. Now we'll be discussing over here. So if it's for alcohol, it is represented by OH and its secondary suffix becomes OL, and aldehydes, it is represented by CHO. This is the way in which we represent this functional group, and its secondary suffix is denoted by AL. And as for ketones, C double bond O is the representation for functional group, and secondary suffix is ON, right? And as for carboxylic acid, the representation is COOH, and its secondary suffix becomes oic acid. And amine is represented by NH2 and secondary suffix is very pretty much similar as its functional group name, that is amine. And for thioalcohol, it is represented by SH and its secondary suffix becomes thiol. Cyanide, it is represented with CN, C triple bond N, and its secondary suffix is generally nitrile. And ester, COOR, its representation, and OH shall be its secondary suffix. And amide, it shall be represented as CONH2 and its secondary suffix is amide itself. And the final one is acid halide. Its general represented is COX. X over here may be chlorine, bromine, iodine, or maybe fluorine sometimes, and its secondary suffix becomes OL halide. You're getting it? Now let's apply this on a homologous series along with the tonoids IUPAC name, right? Over here, if you look at this table, this one, if you look at there are 5 parts. One is homologous series, which I have told you, and the second one is root word, mit, ith, prop, do you remember from earlier class? And next one is primary suffix, which denotes saturation or unsaturation, and secondary suffix, as I've told you, it denotes functional group presence. And now let's try to learn the IUPAC name in total. So for alcohols, say such alcohols are saturated, do not contain any unsaturation, its root verb becomes alk, and its primary suffix, as I've told you, if saturation is there, ane, unsaturation, ane. Over here it's ane, and alcohols, here it's ol. You're getting it? So it becomes alkanol. Consider here CH3OH is there. So one carbon is there, we say it's mit, and there is no unsaturation in, and this is something secondary suffix belonging to ol, methanol. You're getting it in such a manner. Alcohols, say we take unsaturated ones. Root word is alk. Alk is generally for everything. Alk and unsaturated, say we have one double bond over here. It's ene, and as for secondary suffix alcohols, it becomes all, alkenol. Similarly, take unsaturation of an alcohol with one triple bond. We know that root word becomes alk, and as I've told you, it's triple bond, it becomes ine, and secondary suffix is all, and alkanol. Alkanol is the IUPAC name. You're getting it? And next, if we take an aldehyde, suppose from here, let's take all the saturated compounds only. For this aldehyde, say the root word becomes alk, and primary suffix becomes ane, as I've told you, saturated one. And as for aldehyde, secondary suffix becomes al. You're getting it over here, and total IUPAC name becomes alkanal. Alkanol differs from alkanal. You must be very careful with the spelling over here. Ketones, as I've told you, its representation is this one, and we know that root word becomes alk, saturated compound, it's a ane, and secondary suffix it becomes one from this table, and in total we can say that alkanone is the IUPAC name. So take for carboxylic acids, alk, it's a saturated one, as I've told you, ane, and its secondary suffix becomes oic acid, and in total it becomes alkanoic acid. So let's continue in our next page. Say now we take acid chloride, and that too saturated one. We know that what will be its root word, it becomes alk, very good, and ane, as I've told you, it's saturated one. From the previous page, we must remember the secondary suffix is like OL chloride. You remember it, OL chloride. So in total, IUPAC name becomes alkanoyl chloride. You must remember. And now let's discuss what are prefixes. So these should always be kept in mind that alkyl groups forming branches of the parent chains are considered as side chains. This point must be noted. I will be repeating it once again. Alkyl groups forming branches of a parent chains are considered as side chains, and atoms such as chlorine, be it fluorine, bromine, and iodine, or molecules such as nitroso, uh, halogens, and this is nitro, and this is nitroso. These are always referred as substituents, and these are prefixed. These are prefixed with the name of the substituent or the side chain to the root word. You get it? And now let's look at arrangement of this prefix, root word, and suffix. So these are arranged as prefix. If one or more, then root word must be arranged, and then primary suffix, and then secondary suffix. This must be remembered, and you must remember that you must be capable of mentioning the position at which the substituent or the functional group is present, and the functional group is present. And numbering should be given in such a way that numbering should be given in such a way that it should start from functional group but not from substituent. And in between double bond or triple bond, highest preference goes to double bond. This must be remembered. And this is the nomenclature for only simple aliphatic organic compounds. And in our next videos, now let's look at like how to name the compounds with solved examples.